So standard 15, the first part says that the Maclaurin series for a function f is given by summation from n equals 1 to infinity of -3 to the n minus 1 over n, then times x to the n. And then it gives the first four terms of this Maclaurin series, x minus 3 over 2x squared plus 3x cubed. And then it says this series converges for absolute value of x is less than r, where r is the radius of convergence of the Maclaurin series. Use the ratio test to find r. So to find r, we can just do the ratio test, which we know how to do. The ratio test is the limit as n goes to infinity of the general term n plus 1 divided by the general term of n, which in this case is the general term of n plus 1 would be -3 to the n times x to the n plus 1 over n plus 1, and then divided by this original term here, which is the same as multiplying by n over -3 to the n minus 1 times x to the n. And so we can rewrite this expression here as -3 to the n times x to the n times x times n over n plus 1 times -3 to the n times -1/3 x to the n. So we can cancel out the x to the n's and the -3 to the n's. And we're left with limit as n goes to infinity of xn over n plus 1 times -1/3. And that, with L'Hopital's rule, this is when you sub infinity in for n here, that's an indeterminate limit, so we can use L'Hopital's rule to simplify this to limit as n goes to infinity of x over -1/3, which is the same as limit as n goes to infinity of -3x, which is the same as absolute value of 3 times absolute value of x. Sorry, absolute value of -3 times absolute value of x, which is 3 times absolute value of x. So this is our radius of convergence in terms of x, but this limit has to be less than 1 for this Maclaurin series to converge. So that will find us our radius of convergence. So we set 3 times absolute value of x less than 1, and we get absolute value of x has to be less than 1/3. So therefore, our radius of convergence, according to this, it says absolute value of x is less than r, which is our radius of convergence. R is 1/3, so that's our radius of convergence.